Welcome to the Engine Room Simulator Familiarization, Module 1. ERS Objectives. To acquire knowledge and skills to operate, supervise and monitor the safe operation and control of a ship's machinery installation in accordance with provisions of Section A33/1, A8/2 and B8/2 of the STCW Code. ERS Learning Outcomes. Familiarization with the use of instrumentation and controls used in the engine rooms of modern merchant ships. Awareness of the need for proper pre-planning, the use of checklists and of the timescales involved in startup procedures. Understanding and awareness of correct watchkeeping procedures. Understanding of the way in which machinery units are interdependent. Experience in identifying operational problems and troubleshooting them, the ability to make decisions which promote the safety and efficiency of an operational plant. ERS Familiarization. The simulator module is designed for training the cargo ship engine room watch personnel in skill of proper operating the ship diesel propulsion plant systems, including preparing and putting into operation machinery and systems, monitoring their operation by measured parameters with the aid of the alarm system, troubleshooting, SDPP control during vessel maneuvering. Main Engine Control System. The control system for a two-stroke reversible low-speed turbocharged diesel main engine is described on the ME page. The system designed for automated remote control of the ship reversible from the engine control room, and namely diesel slow turning prior to engine start, starting, stopping, reversing, changing RPM and control of emergency or pre-emergency situation. Main Engine Control System, ME page. Freshwater Cooling System. The system is designed for cooling cylinders, covers and turbocharger of the main engine and the diesel generators. Fresh water, which is cooled, in its turn, the cooler by seawater, is pumped through the system's closed circuit. Freshwater Cooling System, FW page. Sea-water cooling. The system is designed to cool lube oil in the ME and DG, the ME camshaft, the cooling freshwater in the closed circuit, the scavenge air for the diesels, the air compressors and the propeller shaft bearings. For this purpose, the seawater is pumped through respective coolers or mechanisms and out overboard. If temperature is low, it is partially recirculated. Seawater cooling, SW page. Fuel oil supply system. The system is used to supply fuel from the service tank to the diesel high-pressure fuel pumps, HPFP. The system allows the main engine and the diesel generators to be run on heavy fuel oil or diesel fuel oil. Fuel circulation in the system is provided by two pairs of electrically driven pumps, supply pump and circulation pumps, operating in the standby mode. Example 1 pump operating, the other one being a standby. Fuel oil supply system, FOS page. Oil and fuel separators, 3 separators. Separators 1 and 2 are used for the fuel oil purification or clarification for choice. Separator 3 is used for the clarification or refinement of lubricating oil. It is possible to combine operation of separators 1 and 2 by turning them on, one by one or in twos, in parallel or serially in different service modes, purification or clarification, depending on the condition of the fuel to be purified. Oil and fuel separators, OFS page. Fuel oil transfer system. The system is designed for fuel storage, settling, pumping, separating and directing to the diesel service tank. The system includes the following components modeled by the simulator: heavy fuel oil storage bunker, diesel oil storage bunker, HFO pump for replenishment of fuel in the settling tank and for other fuel transfer operations. Do transfer pump for replenishment of fuel in the DO service tank and for other fuel transfer operations. HFO settling tank. The fuel separators is designed for removal of water and mechanical particles from HFO fuel or DO fuel. The spill tank is designed as an assurance against overfill of the settling or service tanks. The sludge tank serves as a collector of separation waste, sludge and other kinds of fouled fuel and oil. Fuel Oil Transfer System foot page. Lubricating and piston cooling system. The system is designed for lubrication of bearings and cooling of diesel pistons, for lubrication of camshaft bearings, fuel pump drive cam faces and exhaust valve cam faces, camshaft lubrication system, and for lubrication of diesel cylinders. In the main system, lube oil of certain temperature is supplied under certain pressure to circulation lubrication points, including main bearings and connecting rod bearings, crosshead bearings and crosshead guides, thrust bearing, bearings and camshaft drive, other drives and attached mechanisms. Lubricating and piston cooling system, LO page. Compressed air system. The system is designed for production, storage and supply of compressed air, including air for the diesel start and control. The system includes the following components modeled by the simulator: the system of pipelines and reservoirs as a gas dynamic object, electrically driven two-stage air compressor 1 and 2 with water cooling and an air cooler, pumping air under a pressure of 30 bar to 2 main bottles, electrically driven emergency compressor for pumping air to the auxiliary compressed air bottle, designed basically for starting the DG's duration. Main compressed air bottles 1 and 2. The bottled air is used for starting diesels, the main and auxiliary ones, also for the control system and for service needs, through a reducing valve. Compressed air system, CA page. Exhaust gas and turbocharging system. The system is designed to release exhaust gases from the ME cylinders, to replace air charge in the cylinders and to increase pressure in the diesel cylinders at the compression stroke beginning. The system includes the following components modeled by the simulator: ME gas air paths as gas dynamic objects, ME as a thermodynamic object, turbocharger as a thermodynamic object, an electrically driven air blower. Exhaust gas and turbocharging system, EXH page. Panel for control and tuning the combustion process in cylinders. The panel is designed for diagnostics of the working process in the ME cylinders and for tuning the fuel supply system. Graphical representation of dependence of the pressure curve for a two-stroke low-speed diesel to the crank angle, the so-called indicator diagram. Adjustment of the fuel supply system according to the value of generator dose to each of the cylinders. Adjustment of the fuel supply system on the fuel injection advance angle for each cylinder. Comparison of fuel combustion process parameters between diesel cylinders. Panel for control and tuning the combustion process in cylinders, CYL page. Local ME control post in the ER. The local main engine control post in the engine room is intended for starting, stopping and control of the ME in the mode or manual non-automated, non-follow-up control from the ER, bypassing the remote automated control system. The local control post enables turning on or off of turn gear, diesel turning before the start, turning on/off of the ME auxiliary air blower, diesel start or shut down, diesel reversing, change of the diesel RPM, monitoring of a number of ME operating parameters, ME shut down by the safety system. Local ME control post in the ELC page. The Diesel Propulsion Plant Alarm Station, or AS page. Ship Electrical Power Plant. The Ship Electrical Power Plant Simulator module is designed for training the cargo ship engine room watch personnel in skill of proper operating the ship electrical power system, SEPS, including preparation of equipment or systems for their operation, startup and shutdown, monitoring of operation using variable parameters, troubleshooting. The ship electrical power system is designed or meeting the ship's electrical power demands in standard and emergency conditions. SEPS Control Panel, DG1 page. SEPS Control Panel. The control panel includes Control Mode Switch, DG Priority Switch, SEPS Operation Sub-Mode Selection buttons when in the automatic control mode. The SEPS Automatic Control Mode Selection buttons, Auto Modes, are designed for selection of a generator load mode in the automatic mode. In example, the buttons are active only in case SEPS is in the automatic mode. SEPS Control Panel, DG2 page. Shaft Generator is designed for developing power from the main engine. Components for a SHG, the ship EPP uses brushless three-phase synchronous generators with an implicit pole rotor. The synchronous generator has a three-phase current exciter with external poles, a rotating rectifier unit, electronic excitation, voltage limiter and stop overheating. The stop overheating is switched off automatically when the generators get close to the buses. The SHG power depends on the type and power of the main power plant. Shaft Generator, SHG page. Emergency Diesel Generator. The emergency diesel generator is designed for generating electric power on the ship in an emergency, in case of failure of the DG1, DG2 and SHG. For a EDG, the ship EPP uses brushless three-phase synchronous generators with an implicit pole rotor. The synchronous generator has a three-phase current exciter with external poles, a rotating rectifier unit, electronic excitation, voltage limiter and stop overheating. The stop overheating is switched off automatically when the generators get close to the buses. Emergency Diesel Generator, ES page. Sharing and Synchronization. The synchronization section is designed for selection of a generator to be synchronized, checking phase differences at MSB and at the terminals of the generator to be connected, switching generators to the parallel operation. To perform these functions, the panel includes controls, indicating meters for checking voltage and frequency at MSB and generator terminals, synchroscope. Synchronization Panel, SEN page. Sharing Panel, SHAR page. Main Distribution Switchboard is the central point of power distribution among the onboard power consumers. Consist of the distribution high voltage, 380 volts, and low voltage, 220 volts, as well as the earth insulation panel. Main Distribution Switchboard, DISTA page. Emergency Switchboard, Emergency Generator section. The section is used for connection of the emergency generator, EDG, to ESB buses. Monitoring EDG operation. To perform these functions, the panel includes EDG status indicating meters, EDG alarm protection indicators. The 24 volts DC consumer ESB is designed for monitoring the network and power supply removal to from the consumers. Accumulator battery. The charging unit is designed for monitoring the battery charge level and for charging 24 volts DC batteries. Emergency switchboard ES page. Main circuit diagram. For the modern ship control and monitoring systems, the summary information on the power plant, in example, its configuration, generator statuses, basic electrical parameters, etc., are displayed on the system monitor being referred to as main current circuit. The active, live elements, buses, feeders, closed switches, in the circuit are highlighted in blue. Special waste windows are provided for indication of electrical parameters. In addition to the informative component of the page, the simulator features a possibility to use the mouse to control some MSB/ESB switches, which are not presented on the simulator control panels. Main circuit diagram MCD page. The electrical plant alarm station AS page. Auxiliary machinery and systems. The simulator is designed for training of watchkeeping personnel in the correct operation of the ship's auxiliary machinery and systems, including preparation and putting into operation of machinery and systems, monitoring of their operation by the measured parameters with the assistance of the alarm system, troubleshooting procedures. The set of the simulated systems complies with the currently accepted ship standard. Parameters and performance characteristics of the modeled machinery and systems correspond to the actual ones, as the simulator models all the principal processes: thermodynamic, mechanic, gas and hydrodynamic, electrical, in their interrelation. Steam plant system. Steam plant system is intended for producing steam used as a heating agent in the technical and domestic heaters on the ship. The steam generator is a combined fire tube boiler operating from both main engine exhaust gases and foyer from its own furnace. The following components are included in the system and modelled in the simulator: system of pipelines as a hydro and gas dynamic object, steam generator as a hydro and gas dynamic object, condensate catch tank, electrically driven feed pumps number 1 and number 2, condenser, valve for the control of cooling water flow through the condenser, valves, main steam valve and valves for the delivery of steam to the consumers, condensate collect tank makeup valve, boiler fuel system. The system is designed for supplying fuel to the boiler burners. The system allows the burners to use heavy fuel oil or diesel oil for operation. The fuel circulation in the system is provided with 2 electrically driven pumps operating in standby, one in operation, the other a standby. The fuel is fed to the burners under certain pressure, of certain temperature, which ensures the fuel viscosity of 10 to 15 CST required for the adequate fuel atomizing by the burners, through the filter which guarantees separation of solid particles of more than 50 microns to prevent the burner clogging. To reduce the heavy fuel oil viscosity, it is subjected to heating. Preliminary in the heavy fuel oil service tanks and pipelines, satellite steam lines. Final in the fuel oil heater. The fuel oil heating temperature may be as high as 140 Celsius. To avoid the fuel boiling up, vapor and foam formation, the system maintains an operating pressure of up to 8 bars. Bilge water system. The system is designed for collecting, storing, purifying and pumping out oily water of the engine room. The following components are included in the system and modeled in the simulator. Bilge well. System of pipelines as a hydrodynamic object. Bilge pump, separator, oily water tank. Bilge water system, BW page. Steering gear. The system is designed for enabling the change of rudder angle to suit the ship maneuvering requirements. The following components are included in the system and modeled in the simulator. Hydraulic pipeline as a hydrodynamic object. Operating fluid tank, hydraulic system pump plant, hydraulic drive to the stock, automated remote control system. Steering gear, SG page. Water desalination plant. The water desalination plant is designed for producing fresh water for the technical and domestic needs from the seawater by the vacuum vaporization, followed by the condensation. The distiller includes heat exchangers which perform functions of an evaporator and a condenser. Due to the high vacuum, 85 to 90%, the brine in the evaporator boils at the temperature of 52 plus minus 5 Celsius. The vapor rises and passes through the demister where it rids itself of the water admixture and is fed the condenser where it is cooled with the seawater. In the condenser, the vapor is condensed and pumped out into the distillate tank. The plant capacity is from 0.5 to 10 cubic meters per day. The water level in the evaporator is maintained at a constant level by the overflow. Part of the feed water turns to the distilled water, whilst the remaining brine is constantly pumped out of the evaporator by the ejector. As a rule, the plant operates in the automatic mode. Central Fire Alarm Station. The Central Fire Alarm Station is designed for the permanent monitoring of fire safety on the ship, remote control of the fire extinguishing system, fire-resisting doors, ventilation and cut-off valves of fuel pipelines. The system includes the ship fire alarm panel, remote start panel of the engine room CO2 system, remote start panel of pumps 1 and 2, fire doors remote control panel and remote control panel of fuel supply system cut-off valves, and emergency stop of fuel pumps. There is button for producing the general alarm signal throughout the ship. Central Fire Alarm Station FA page. CO2 station. The CO2 station is designed for the extinguishing of heavy fires in the ship engine room, boiler rooms, cargo spaces, etc. The system start is controlled from the CO2 station screen page, CO2 button, and from the Central Alarm Fire Alarm Station screen page, FA button. The following components are included in the system and modeled in the simulator. Set of main CO2 cylinders, pilot CO2 cylinder, servo cylinder, main valve, pipeline with non-return valves, remote control and alarm system. Fire main and foam system. The fire main system is designed for extinguishing fire in all the rooms on the ship. Along with the fire main system, the foam system is used for extinguishing fire in the engine room, pump room, boiler compartment, and sea and other rooms and on decks. High expansion foam, 1:1000, is used for firefighting in the engine room and pump room. The main equipment and controls of the foam system are arranged in the foam system station. Fire main and foam system, FM page. Provision cooling system. The automatic provision cooling system is intended for creating and maintaining the set temperature conditions for the storage of food in 2 groups of provision stores. The following components are included in the system and modeled in the simulator. Provision stores as a thermodynamic object. Refrigeration plants number 1 and number 2. A gas liquid lines with valves as hydro and gas dynamic objects, cooling seawater pump. Provision cooling system, PC page. Air conditioning system. The central straight-flow twin-channel high-pressure conditioning system is designed for the year-round moisture and temperature treatment of the air in the accommodation spaces, mess room, and other rooms on the ship. The central straight-flow twin-channel high-pressure conditioning system is designed for the year-round moisture and temperature treatment of the air in the accommodation spaces, mess room, and other rooms on the ship. The air is propelled through the conditioner by the centrifugal straight flow blower with an electric motor and air filter. When the blower is operating, its operation indicator lights up on the mnemonic diagram. The following components are included in the system and modeled in the simulator. System of pipelines as a hydro and gas dynamic object. Refrigeration plant, cooling seawater pump. Steam air heaters, air coolers. Centrifugal straight flow blower with an air filter. Moisture control unit. The alarm station for auxiliary machinery console. The end of Module 1, Engine Room Simulator Familiarization.